Hi all, I'm Vijay Jethani. So in continuation to our previous masterclass that was on automated ops, in today's masterclass we are going to cover Terraform. So let's look at what is our agenda for today's masterclass. So we are going to cover why we need Terraform at first place, and we will cover how it sets Terraform apart from its competitor. We will look into how Terraform works. In this, basically, we are going to talk about configurations required and what are the basic binaries and how actually is the flow from code to deployment. So this we will cover in how Terraform works. Finally, as we are maturing ourselves on using Terraform for implementations, we need to understand how we scale it for an enterprise, how we have to adopt these standards for enterprise so that irrespective of where we deploy or automate our infrastructure as code or configurations, we are able to make best use of it, also help us reusing what we have already made. So that is covered in the third part. Fourth, we are going to cover the Terraform editions. While most of us are using the community edition, but there are other editions which we need to know from Terraform per se. So that will be covered in the fourth part of the agenda. So from first till fourth, we are going to cover some basics of what we need to know from Terraform and how we need to configure Terraform and implement it to our requirements. From fifth onwards, we are actually going to deep dive into our code. Now, this code is nothing but we have to set up an infrastructure on AWS for Kubernetes, and similarly, we will deploying the containers on that. So we are going to take help from Terraform for the coding and implementation and CI/CD. We are using GitHub Actions. So it will be combination of Terraform and the GitHub Actions for our implementation of Terraform. Finally, we are going to review this implementation so that you understand end to end what we have done from start to end. Okay, so this is a brief agenda before we move further on Terraform masterclass. Also team, if anyone wants to revisit previous masterclass, that was all basics about what the automated ops are. So when I say automated ops, we covered the GitOps, we covered DevOps, we covered the data ops. Similarly, we covered also the ML ops. So while that was a basic session, that is important for you to understand how we automated the operation. And this master class is specifically on Terraform. Hence, we are learning about how we can integrate our GitOps, DevOps, as well as Terraform here. Okay, so this is an extension of our previous masterclass, which we did on automated ops. Now let's get started with our first topic, why Terraform. Now in a nutshell, Terraform, you can see this as a three blocks. First is a Terraform itself. Now Terraform is written in the Go language and it uses the language which is called the HashiCorp language. That is the reason we call it HCL. It is nothing but the declarative language plus addition of what we have seen in our programming practices. Okay, so that makes up our HashiCorp as a language for implementation, or I would say for automation. The second part which you see as a Terraform provider, these are nothing but the platform providers. You can consider it, for example, as the cloud platforms like AWS, Azure, even Kubernetes from an open source per se. So what Terraform does is it has its own language which writes the code on top of the provider. Now, when I say provider, it will give us the APIs which we can consume directly from those platform providers. And finally, at the last stage, which we see as a target platform, we are going to implement that on those target platform. So what we are going to get out of this box is first you have a binary provided by the Terraform itself, which is nothing but an automation platform. Providers are your first party or which specific implementations you want to do with the Terraform in a simple sense. And third part is where you want to have your implementation done is your target platform. Okay, so all three is a basic in a nutshell what the Terraform is all about. Now, to know why we are actually using Terraform, we have to understand what it does separate from its competitors. First of all, Terraform has a pre-built integration. As we have seen the providers, it provides a binary, but it is equally dependent on the providers. That means it is a near native to cloud platforms. Whether I'm using Azure, whether I'm using AWS, whether I'm using Google, whether I'm using Kubernetes or any of the platforms which you might have done the implementation, it wants to use them in the cloud, bare cloud way with the help from the Terraform binaries or the APIs. That means we are not changing anything. That is the reason it has the huge community which is continuously working to get us up and running on the different providers from the Terraform. So it has a vast use of the platforms, as well as I would say all the cloud providers have the support for Terraform. Most importantly, what we have been using so far is we were getting, you might have seen in Azure, you have resource manager. Similarly, in AWS, you have your cloud formation. The Google also has their own implementation. Similarly, the Terraform will have its own, the Kubernetes will have its own implementation. So everyone will have their native way of infrastructure as code. But what Terraform has done is it has provided you not only the out of box declarative coding, but also provide you the state management on top of that. When I say state management, that means we are able to actually check till what particular level of infrastructure was deployed, what was the state of that, whether we need a redeployment, complete redeployment, or whether we do the incremental redeployment. So those are the steps you can take directly from the Terraform. So that is the reason you have a secure state management. And from the programming practices, if you are working today, whatever languages which you have seen, which I was talking about, resource manager and the cloud formation, you have a declarative coding, but they don't have or they lack the skills in form of how do you iterate. Like if I want to apply the for loop for as simple as if I want to implement on 3 geographies, I want to do the repetitive installation of same services on those 3 geographies. How do I do that? I obviously have to copy the codes for these 3 geographies, which is waste of the not only the space or but also on the code does not look the clean. So from the programming practices, Terraform has its way of looping or iterations, which can help us rather than repeating the code. We can make use of the loops as well. Okay, so it has advantage over its competitors. Now, from an infrastructure perspective, Terraform treats everything as a new deployment. That means even if I change small thing, it knows what has to be changed based on whatever the state was. If I'm starting completely new, obviously there is clean slate. It will try to install everything on top of that. But if I'm running it second time, it will only change whatever is the change in the code. So from infrastructure per se, only the incremental changes are being taken care. Now, other thing is idempotency. This is nothing but the state management for incremental. As I already have the state management taken care at my Terraform level, I did not worry about what was there from the previous deployments. It already has the history of that, so it replaces whatever has changed. Okay. And community support. Terraform has huge community support, and it also releases the specific bugs and fixes along with the security patches at the regular intervals. So we did not worry about whether coming years it will be supported or not. Yes, it will be, there will be changes, positive changes going forward. So obviously there's a learning curve, but then from a stable software, yes, it is a stable software which we can utilize for our automation or infrastructure as code. And final thing is, don't consider Terraform as a configuration management tool like Chef and Puppet. It is an automation tool which make best use of our cloud native products or platforms and do the automation on top of that. It just provides us the APIs for consistency, for state management. So if you remember these three things from a state management perspective and also the consistency which you get with the Terraform, you will be able to utilize this fully. Okay, so I will just pause here for a while before we move further. Okay, so that was on why Terraform. Now let's see how Terraform works. Now, if you have to create any Terraform project, the bare minimum configurations, or I would say the declarative code which you have to write is in form of Terraform configurations. Those are nothing but .tf files which you see here. And side by side, you will have a container which you can consider as a bucket, or you can consider this as a blob, some file which actually maintains the state of your implementation. So from a configuration per se and the state management per se, you have these two files. Now, while working with the providers, it actually creates the plan. Now, what is the plan? Plan is nothing but based on the configurations you have put in your code, it will create what I need to implement from the bare metal on which you are from start, what exactly I have to build on. So it actually creates a plan. And also while it creates a plan, it also creates a dependency. That means if in the code itself, it knows from the provider that, say suppose example, if you are going to implement something on AWS, so before anything can come up, I need a networking, I need a storage, I need a VM. So those all things are our dependencies. So it creates a dependency graph before you can create a cluster on top of that. Okay, so the plan knows based on your configuration what has to be implemented and in which sequence. So as simple, the Terraform plan provides you a step-by-step approach what needs to be implemented. Finally, based on what you are going to implement on a respective providers or respective platform, is with the help of Terraform apply, you just do the implementation of what you have coded so far. Okay, so from Terraform per se, these are the three things. First is you do the configuration, or you write the code, you plan for it, and finally you deploy it. So these are the three steps which you need to remember while you are working with the Terraform. Okay, again I will pause here for a while before we move further. Now, why do we need Terraform adoption phases? So Terraform adoption phases, I think it is as simple as of now, if you're learning something, you are actually learning as a novice, you are starting fresh, right? So you are adopting that particular technology is your first phase. You are adopting to the Terraform is your first phase. That means how to configure it, what kind of resources you will need, how you are actually creating the dependencies, how you actually organizing your code, how you are creating your workflows. Those all things you need to learn slowly. Once you are up to the speed, I need to make sure that I do the collaboration with the team in terms of reviewing that code and having the version control. Now this version control is nothing but whatever we have been doing so far with our Git based distribution control system, right? So you do the version control on that, you review your codes and finally promote it to the production. So that is what you collaborate, because we want to make sure that every small feature is captured and reviewed, approved, and then promoted to the production. Okay, so this is all the same features which you have been learning from the DevOps per se. Now, once we have that mechanism in place of version control, then we go to the scale. Now, scale is not just about making the uh, provisioning the clusters, but also want to make sure whatever you implement from an infrastructure as a code, you know what is in scope versus out of scope. Terraform can be, cannot be. It is based on you, how you want to manage the scope. Say suppose if you want to have only a few part of your infrastructure to be managed by Terraform, then in that case your scope is only those particular resources, and the rest of the resources you can deploy manually, or you have different tools, purely up to you. So Terraform gives you that flexibility or scale where you can decide what is managed versus what is unmanaged in a layman's term. Okay. Finally, as you are going to scale, you need to think from an enterprise per se. Today I'm using version 1. Tomorrow I will be going to version 2, version 3. How I need to lock down this environment so that while I promote this code, it I have appropriate policies and strict controls in place so that whatever is being deployed is done in appropriate fashion. Okay, so that is where the govern phase come into picture. So I want to make sure that all my enterprise deployments are following a particular pattern, having an approvals in place, appropriate collaboration in place, and only the production go ahead is given, then only those are particular implemented in a appropriate fashion. Okay, so just to give you brief, this all about the Terraform adoption phases. And team, I'm just going brief on those because you may already know this concept, but someone who's starting fresh, for them it will be just at least know-how of what we are trying to do the implementation today as a part of masterclass. Again, I will pause here for a while before we move further. Okay, so now let's move to the additions. Now, as a part of Terraform additions, we all are using the publicly available community edition, or we also call it do it yourself. That means we own the code, configuration, state management, whatever is required from the Terraform. If there are any bugs, fixes, we go and troubleshoot those particular things, resolve on our own. We don't have any support apart from our community support. So that is your Terraform community edition. But if you are using HCP Terraform, which is nothing but the SaaS platform, which is provided by Terraform, in that case, you get a support as well. And in that is nothing but you can consider this as a complete SaaS service where you utilize the state management, you utilize the complete infrastructure, or I would say a management console itself from the Terraform itself. And while you grow ahead, you also, because HCP Terraform is the PaaS or SaaS services which is provided by Terraform for a small to medium. But if you grow to the enterprise scale, you want to have the similar kind of environment which is SaaS hosted on your infrastructure. So in that case, it provides a self-hosted Terraform on your data center or your particular platform. Okay, so remember, this is just the brief just to get you started. If you want to read more on this, I think Terraform has a very good documentation. You can go and read them. The scope of this particular masterclass is to get you running as quickly as possible. Hence, I'm giving this brief. Okay. So now let's get started with our code. Okay. So I have a complete repository. So I'm just going to that code base, what we have. So let me start from the, okay. So these are the workflows at first place. I will just explain you in brief before I cover what exactly we have in the Terraform. Okay, so let me cover Terraform first, and then I will come to the workflows. So you have two parts here. First is from Terraform per se, I have to create first of all infrastructure. And if I say infrastructure, I have to make sure all these Terraform versions, as we already talked in our theory, we need a providers. So we need a provider of AWS. Similarly, we need a see, there are a lot of random, as well as you will see the different providers. Each one is kind of providing some other kind of functionality. Okay, so it generates the way we generate the random numbers, random strings, and all those things. Random is used for that. So you will understand that slowly, but I would just brief you about what this code is all about. So important file is one is version. So you will see what kind of the infrastructure versions or providers you're using. Then other important is what kind of the variables. Now, similar to what we do in our DevOps as well, we set up the what will be the name of our environment, what will be the application name, which is a primary region we are using. So these are the similar kind of the variables you will see. And finally, what is the type of that? That means what kind of the data it will be inputting from us. Okay. And based on that, we will also be fetching those details. That means we will be setting or pre-populating the details on based on what implementation we are going to do. So in our case, environment name is development, application name which I have given. I'm setting the region as US West 2, and the image pusher, this my name, I'm creating the user for that. And finally getting the networking and rest all things for the cluster per se, including the what kind of the Kubernetes environment and what kind of the service account I will use for that. Okay, so remember, this is purely the infrastructure related node which we are going to infrastructure, all the infrastructure which we require for Kubernetes cluster, we are setting using the Terraform. So these three files were important, which I'm showing. Other files also you can go and walk through. What are we going to set into that? Everything you will see what specific resources we are setting up, like say network. Okay, similarly security, front end, back end, and main is the file which knows basically, or I would say that is the heart of whole while you start with the Terraform, because ideally if you are not modularizing that, everything will be fitting in the main file. But in this case we are actually modularize each and every component with a separate file. So this looks nice here, so that you are able to understand. As of now we are just applying the tag filters or in creating the resource to, that's all. And just giving a partition name and the identity which I am implementing this particular Terraform. Okay, so at this point of time, at first place, I will just explain you the infrastructure uh, which we are going to implement as a part of Terraform. Okay, once you have the code, I think you can also walk through that and go through each and every file in more detail. In interest of time, I may not be able to cover all of them, but at least giving you the brief of what exactly the code looks like. Okay, now here in our node groups of the cluster, what I need before I can do the before I set up the containers is what is the minimum size, what is the maximum size, and how the cluster configurations needs to be there. So those all things I have already mentioned here. Similarly, from the container cluster per se, what are the subnet IDs or what kind of the configurations, again there is a separate file for that. Okay, so that's about the infrastructure which we are doing from a Terraform. Okay, and as I'm implementing, I will also show you step by step. So first step for us as a part of our implementation is to go and create the a bucket for state management. So I have already created that bucket. So I'm already logged on to the AWS and I have created the Terraform bucket where our state management file will sit in. As of now, there are no files because we are yet to start with our implementation. Okay, so first step is to go and create the S3 bucket. Okay, so which just you have to just go to Amazon S3 and create the bucket. Okay, and give the name Terraform. Okay, then for you, this is just xxxx. I have selected 0077. You can select any so that it is unique and you are able to consume that. Okay, so again coming back, the important thing to note here is first we have to set the bucket for state management. Once we are done with that, then only we will start with our infrastructure implementation. Okay, so as a part of our workflow, we are going to do the deployment using GitHub Actions. Now let's come to the GitHub Actions workflows. Now you have to start with Terraform plan. This will actually do the initial configuration of Terraform. That means initialization of Terraform. And remember, as you are authenticating with the AWS, you have to create a access key. So that is where all your variables as well as secrets need to be created and stored in GitHub Actions the way we used to do in our normal GitHub workflows. So hence I'm not explaining that in detail here, but I think if you are well versed with the GitHub Actions, you should be able to get that fine. So there are variables as well as most of them are the variables. Only where you have the passwords, you have to fetch them in form of a secret. Okay, so the first workflow which you will run for Terraform initialization is Terraform plan. Okay, and remember this bucket name region and we already created, we have stored those things in our secrets. Okay, so let me show you one again. The file which is important for us is the Terraform variables. Okay, make sure you understand this, and based on which region you want to select, you can change here what kind of who will actually manage your image for the containers. You can just set your name here and create that user in that particular AWS environment. Okay, you can keep these things as a default, changing few of things which you want to change, but ideally if you keep everything default as well as will work, make sure you are giving the unique name to the your environment and application. Okay, so rest, I think infrastructure. Uh, while we do the cluster, I will explain the K8s part after that, so that we are going step by step. We are going through the code, implementing that, coming back and coming to the code and again implementing that. Okay, so you understand step by step perfectly. Okay, so let's go and run this Terraform plan, which is our first workflow. And after that, we will apply those settings. As I said, plan will just create what you need to do, and apply will actually implement them on your infrastructure, which is AWS here. The instructions will be similar, the access keys and everything will remain same. The only difference is previous just create the plan one just created the plan looking at the configuration file, and apply will actually implement those on your infrastructure. Okay, so that is the difference. So let's go with these first two YAML files or workflows. First is Terraform plan, another is apply. So let's start with our GitHub Actions. I am trying to the Terraform workflow. Okay, make sure you create the bucket before running this Terraform plan. Otherwise, you will get the error that there is no state file available to be stored. Okay, so if you see, it created the plan based on our configurations, or I would say all the Terraform configuration. It started with the main, it created a resource group. Okay, and then it gets all the dependency mapping. It does all what you require from a configuration per se. It creates each and every plan based on the dependency map it creates. Okay, so it is huge file. If you want to go through it while you are implementing it, pause on this and see what exactly it is trying to create a plan and match it with what you are actually getting implemented in your platform. Okay, so everything it creates based on our configuration. Now this was our first step. Now let's try to apply and create our infrastructure using Terraform and GitHub Actions. Again, here you have to just run the workflow on the respective branch and it will create the infrastructure for you. See, it is applying the Terraform. Whatever plan we have created, it will follow that particular plan and create an infrastructure for us. So it has started creating the environment now. You can just see creation complete, creation. So it goes from right from VPC, all the network subnets, then roles, then you need to have all the policies in place. Each and everything is well thought of. All your access, getting the cluster up and running, getting the right nodes in the place, and finally giving you the environment up and ready for your containers to be deployed. So we have to, this will take some time because it has a lot of the work to do. Parallelly, you can go and check here as well. Say suppose if I want to really go and check for whether my state file is created, I will just go to S3. Just want to show you that the state file is created within that bucket. See, state file is created. Okay. Now also again, I want to check what all resources are being created. I can, for like say suppose if any cluster is being created, obviously I should be able to see something happening here. See, it is in a creation mode. So we want to make sure that while we are deploying this, we are simultaneously checking this on our AWS environment as well. As this is fully automated, you will get all the load balancers, you will get the ingress and everything once we finish this whole setup as a part of deployment. Also, you can just try refreshing so that you are you know that obviously something is happening while you are creating. Okay, so I think we will wait for this to complete, and meanwhile we will shift back to our code to understand what we have as a part of our Kubernetes deployment. Okay, so let's do that. So let me move to the code, going back to the source and going to the Terraform. And okay, so while I create this infrastructure, now I want to make sure I have all the required, first of all, components of the cluster itself. Now again three important files which I normally say start with versions. This will give you what kind of the providers you are using. I'm using Kubernetes version. Similarly for Helm, I'm installing this particular version. AWS, you have all the providers in place. Similarly, what primary region which you are selected, which identity you are using, these are all the common things. But at least you know what kind of the, from a Kubernetes per se, what version I'm using. Again, second thing you have to check is the variables you are using. A few are repeated, whatever we have set as, but from the Kubernetes cluster per se, account name, namespaces, these are few things which will be new in this. Web app image, web API image, because we are going to have a front end and back end. That is the reason we are having this. Here you will have an ingress controller, because here you have a reverse proxy which is going to hit from an outside to inside. So it has to load balance the service and getting you to the containers. Okay, so make sure you understand these particular what variables we have, and finally how we are setting them up in the some of the variables which you have to provide for implementation. Okay, so what kind of the naming conventions you see from a web app image per se, web API image, and finally you will have a application name, environment name, and the namespace. So these are the few things which we are supplying as a part of our implementation for Kubernetes cluster. Okay, now apart from this, you can see what controller is, what version we are using, service type, annotations, your namespaces. I think here we are using only one namespace, that is only app. Once you have done with that, you have the load balancer ready. And how do we expose our apps? Obviously using an ingress resource, and this is what this particular Terraform file does. It exposes your root, which is your front end. Similarly, your back end is your API. Okay, so that those are the way how you can reach to your containers. And obviously you have the deployment files for a respective web and web API. And how do we share the secrets? How do we store in the AWS secrets manager? For that we are using this particular, and these are the data keys and key value pairs you can say, and the secret name which we are storing in the AWS secret manager. Auth is your OIDC, which we are using for authentication, as well as your kube system. Okay, so this is the configuration we are having for a Kubernetes. Again, same thing, you also need to know about which workflows you will run. Again, you will run the K8s plan, which is similar to what we have seen for infrastructure. The only change here is now we are doing a Terraform cluster deployment along with your ingress resources, role creations for the cluster, which is a Kubernetes on AWS. Okay, rest all things I think you will look similar from the workflow per se. Again, this will create a plan. It will have dependencies, how you get implemented, and finally you have the K8s apply, which will actually create your AWS, or I would say finish your cluster, Kubernetes cluster up and running before we can have the containers running on top of that. Okay. So this is about KTS. Also, until I think this finishes, we can also go and look at what kind of the web app and web API which we are creating. So let's look at that as well. Again, this Docker front end is nothing but this is creating, basically this is a CI pipeline which is building your image and pushing it to the registry. Okay, so here the first part is getting the build run, and then finally publishing is actually publishing it to the registry, uploading the creating the package and uploading it to the registry. Okay, so this is with the help of whatever credentials we have created so far. Okay, this is again the workflow file, and the source for this is again kept in the .NET, both backend and the front end. Similarly, for your backend YAML as well, this is creating your API, and procedure remains same. We are building it, having the dependencies and publishing it, or I would say creating a package out of it, uploading that package or image, I would say, and creating uh, the container out of that in the Kubernetes. Okay, so this is all you have in our workflows. So what we normally do is we normally start with Terraform plan and Terraform apply, and then ideal way is to go to creating the Docker container so that you have registry ready. But I think I will leave it to you if you want to have defer that and do the image creation afterwards. In our case, I think it is always better to have images created. So what I will do is, before even going to the Kubernetes cluster, let's have the image ready, both front end and back end, so that we are able to show you also the configurations of those images appearing in the Kubernetes cluster while the containers are running on top of that. Okay, so let's follow that as a path. So as of now, this is about to getting complete. So I think should be there in any moment. I think I will also refresh the cluster where it is. Okay, so it's active. So at least we have something running from the infrastructure per se. Okay, now one thing which we have to do manually is, which is at this point of time, the gray area I would say for Terraform per se, is the CRDs. CRD is nothing but your the binaries, uh, custom resource definitions. Okay, so these are nothing but the installers on which basically like similar to the way the providers are being, it requires something uh, as a resource. The way we have resource manager shell, it requires something as a CRDs before it can understand the instructions from Terraform. Okay, so what we will do now here is we will connect to this cluster. Okay, so let me connect, first of all, get the identity of how I'm logging on. So let me pull down the, so this is the identity with which I am actually running as of now. Okay, so it will get me connected through shell, and now I want to make sure whatever Kubernetes cluster we have created, I am connecting to it. Okay, kind of kube config. Okay, getting the kube config on my shell. Okay, so now I am connected to the cluster. Now here you can get nodes just to see that you are up and running. Yes, we are good. The only thing it does not have in a AWS shell is it does not have Helm installed. So I'm just trying to install the Helm as well before I can issue any command for the CRDs. Okay, so I'm getting the Helm 3 installed on the shell. So you can just check it if it is available. Just you put Helm version. Yeah. Okay. Now I want to make sure before I can store the secrets in Kubernetes cluster, I want to have the secrets provider class installed. So for that, I have to have a chart available to me, or I would say I want to add the repository. So I'm adding that repository. So as it's already added, so it is skipping, but I think if you are doing for first time, you will need that. So I'm just using the command lines to install the, again, just look at what I'm trying to install. I'm trying to install in the namespace kube system CSI secret store secrets driver, and I want to make sure all the local secrets are synced to this Kubernetes. Okay, so I'm just trying to enable that. Okay, so we are good with that. Now, how do we know? It is also giving us the command line as well, which we can run to check if it is up and running. It will be running in a form of pods in a kube system namespaces. So we are good with that. Okay, so it is up and running. Now, one thing was installing the CRDs. Other thing which we want to have is we want to also install the AWS provider, secrets provider for that. So we also want to do that. So let's do that as well. As I've already had this before, so it is already having. So I'm trying to install the AWS T. Okay. So as of now, I think our secret store driver is installed. So I should be able to now replicate my secrets or even store the secrets in a respective uh, from with the help of Terraform. Okay, create and store them with the help of Terraform on AWS Secrets Store Manager. Okay, so now let's go back to our workflows. So I'm just pulling it back. Let me go back to the workflows. Okay, so let's start with our Docker builds because these are the images which we'll require while we provision our cluster or create the containers. So let's start with that. So what I will do is I will run, say, let me run the front end first. And while it runs, we will also simultaneously see whether it is building properly and pushing it to a appropriate registry, which we will check through AWS again console. So these images are without Terraform. This has nothing to do with Terraform. You are just building a normal package, uploading into registry, and running a workflow using GitHub Actions. Nothing to do with Terraform. Only thing what you are deploying in Terraform is your infrastructure, and another thing which you are just going to see is how do you create an ingress resource controllers using the K8s workflows. Okay, so I'm just coming to that, just giving you a heads up. Okay, so it is now trying to push that to a registry. Okay, getting to the final job. Now this is built and pushed. Let us see if it is available for us. So what I will do is again go to the AWS respective container registry service. So here it is Elastic Container Registry, and I have done it for front end. So it will go to the front end. You see it with today's date and time, right? So you have this as of now running. Let's do same thing for the backend as well. Going back to the actions, backend, run workflow. So steps for both API and that is the backend as well as your front end, which is just app, that is web app. The steps are same. You are just building the image, creating a package out of it, and finally pushing to the container registry. Okay, so there is no change. These are the simple, the normal you how you do the build and the package stuff. Okay, so this also is done. So let us check in our container registry. Now this was for front end. Make sure you just see this image tag because we are going to need this while you deploy the Kubernetes cluster configurations. I would say you do the Kubernetes configurations. So you will need this tag. Let me come to the repositories back and see for backend. Front end it was 7 I think at last. Yeah, 7. And for this backend I think it is 10. Okay, 10. So where I'm going to update this is what I'm just, so while I do this Terraform deployment, I want to make sure I come to the K8s and in Terraform variables, I want to update the front end with image tag of 7 and this as 10 so that it picks up the latest image from registry. Okay, now let us go back to our actions and do the Kubernetes configuration. So we have already seen this plan. Let's try to run this. This is going to check whatever the infrastructure it requires before actually doing configurations. Because this is required in case you don't have a cluster setup or the infrastructure setup for the cluster. I think it won't be able to configure anything. Hence, it is doing the infra checks at first place and creating association, including refreshing the estates, the way you see for registry and everything. It requires these things before it moves further for actual configurations of cluster. Okay, now it will come to actual configurations of K8s. Okay, so let's see what it is trying to do here based on our code for Terraform. Okay. Now important thing for which we did the manual configurations, make sure, yes, this is the part of all your key value pairs as well as the secrets are stored in your secrets manager, a provider class. This is important for which we did the CRD installation. Okay, so make sure this is available and you are able to make sure that the resources are created and everything goes fine. Okay, so this is the plan for which now let us apply that particular plan, see that is able to get all our configurations right. Okay, so let's move on to the create a supply. Okay, so as a part of plan, it checks, does all the checks of all respective CRDs are installed, and so that during apply phase it is not failing. Okay, so this is where it will now actually apply this on the target environment. So you have three steps. One is you write your code, you plan it so that you know the dependencies and how those needs to be implemented. You plan for it, make a sequence, and finally you apply it. These are the three steps in Terraform which you do quite often for any resource you deploy on the target environment. Also, as this is the first time it is running, it will do the complete configurations. In future, if you want to just a small part of the code change, it will only do the incremental. So it will actually take the what it was from the state file. Okay, so while you are learning this and getting mature on this platform, I think you will understand the complete process. Okay, so it is creating the different resources. It has started with creating the web API, web app, and also I believe it started with the identity ingress as well as, yeah, cluster role and everything. So whatever files you have seen from Terraform per se, it is trying to create them as a part of the, yeah, here it is creating the ingress now. Let's see. Okay, ingress also got completed. Finally you are up and running. Okay, now for us to check, we need to go to the cluster. So let us go to the cluster. So you come to the cluster. Okay, so this is our cluster. You come to the resources. Do the basic checks of, say, you can start with compute. These are the nodes which it has created. Similarly, you will find the node group. You can check the networking, subnets, security groups. Resources is where basically you will find all your replica sets. All are green. Deployments, all are green. Now, for you to actually go to the front end, you will need a ingress resource, right? So for that, I'm just coming to the services and networking and getting the ingress resource, which is this, and just checking the load balance URL. So this is what you have to also do that for checking what is the front end. Ignore this. I think as this is a self signed, I think just click on continue. You should be able to see the website running. Okay, so this is your Terraform deployment or the container, which I say, which we just deployed. Okay. So this was the deployment, end-to-end deployment, which we have done with the help of Terraform. Now, if you just want to recap what we did, I can go back to the whatever we have done so far in actions. So we started with few basics of Terraform, and then we came to the code. I think basics you can read through either through the documentation or through the Terraform websites, whichever way you want. But important thing from an implementation per se is you have the code, source code divided into the Terraform deployments and the GitHub workflows. Okay, so if I come to the source, you have in Terraform, you have infrastructure setup and you have a Kubernetes cluster configurations. But before you deploy the Kubernetes or do the ingress configuration, make sure you have the images deployed. For that reason, I think we have these .NET images for front end, back end, which are deployed through the workflows. Now, if you come to the workflow files, sequence which we followed was Terraform plan and Terraform apply. This is the bare minimum basics of getting your infrastructure up and running. Once you have infrastructure up and running, make sure you have the images also pushed to the build and pushed to the registry, because infrastructure is ready. So obviously the container registry will be ready. So you have the front end and the back end. Once you're done with that, you come to the KATS plan and do the apply. So these are the 6 workflows, GitHub actions which you have to run before you can complete this implementation. Okay, coming back to the our actual agenda. Okay, so we covered everything, why we need Terraform, how Terraform works, adoption phases, additions. These were more of a theory. From here onwards, I think we did the coding and did the end-to-end deployment. Okay, so that's all for today's masterclass. Thanks.